Hello guys, welcome back to the YouTube channel. In this video, we're going to discuss factorial of a number and power of a number. If you are new to the channel, in this playlist, we're going to discuss most commonly asked coding questions in C, Java and Python. So we are in the getting started topic, and the first one is factorial of a number. So first, you need to know what exactly is a factorial of a number. The factorial of a non-negative integer n is the product of all positive integers less than or equal to n. So it is very simple. Let's take, we have n. So basically n factorial is equal to n into n minus 1 into n minus 2 into, so we need to multiply up to 1. So 2 into 1. So basically this all numbers multiplication is called as factorial of a number. But there are some important factors here. So the first point is, so factorial is defined only for non-negative integers. So this is the main thing to remember. So non-negative integers. And you need to take one more thing also, which is a 0 factorial is equivalent to 1. So you may ask a question like, why 0 factorial is 1? So in a theoretical also, like in combinational logic, factorial represents number of ways to arrange items. So if we see in that way, number of combinations of n numbers to be arranged in n distinct places, basically it is n factorial. Like if we have n places to arrange, like example 1, 2, 3 places, how many ways you can arrange? Like here 3, 2, 1. So basically if you multiply this, you will be getting 3 factorial itself. But so here when n is equal to 3, but if we see n is equal to 0, like there are 0 objects, there is only one way to arrange them, that is equal to null or empty arrangement. So doing nothing is also a unique action, right? So that's why 0 factorial is equal to 1. If you want an algebraic solution for this, so basically we have one more thing also, which is n factorial is equal to n into n minus 1 factorial. Fine. So now let's go and substitute n is equal to 1. So in that case, what happens? So 1 factorial is equal to 1 into 0 factorial. So we know that 1 factorial is 1, right? So 1 is equal to, obviously, if we multiply 1 with 1 only, you will be getting the 1. So 0 factorial is equal to 1. So this is the two ways of proving 0 factorial is 1. So what approach you will follow to solve this problem? So it is a very basic approach. Just run a loop up to n times and just multiply, and you will getting the answer. It is very simple. So what's the logic here? So just initialize one result. One variable, and one more thing, this is also important. You need to initialize a number which is multiplicative identity, that is equivalent to 1. Why? Because we are multiplying it, right? So that's why if we initialize this with 0, for any input, the answer will be 0 only. So you need to remember that you need to initialize a variable which is equivalent to 1, and then just run a loop. So in that loop, that should run to 1 to n. So it should not start with 0. This is also you need to remember. If you start with 0, obviously the answer will be 0. And every time what you need to do, you need to multiply. So multiply my result with each number. With loop number. And at last, print result. So very simple logic. Let's take one example. Let's take n is equal to 5. So in that case, what we will do? We will initialize one result which is equal to 1, and after that we will run a loop from 1 to 5, right? So 1, 2, 3, 4 and 5. So we have run a loop, and every time what we will do? We will multiply my loop number with my result. That's it. Number is 1, multiply with my result. So my result will be equivalent to 1 itself. After that, in the second loop, multiply my 2 with result. So then result will be 2. In the third loop, multiply my result with 3, which is 6. And next, 6 4s are 24. And next, 24 into 5, which is 120. So basically, when 5 loops are completed, my result will be storing the factorial of a number. So this is equivalent to n factorial, that is 5 factorial, 1 into 2 into 3 into 4 into 5, which is equivalent to 120. Yeah. So let's solve this problem. So first let's take n. Let's take n is equal to 5, and after that we need to initialize one variable, right? Result. So result equal to, we need to initialize with 1, and after that we need to run a loop. The loop should go from 1 to n, right? So for I in range of, so we need to start from 1 and we need to go to up to n. So here the range will be n minus 1, right? So we need to give n plus 1. Yeah, and after that, every time what we need to do, we need to multiply our result with the loop iterator, that is I. So we can write result is equal to result into my I. That's it. And after completing every loop, it will just my result will be storing what is the factorial of a number. We need to just print it. So print factorial of my number n is, just print the result. Yeah, that's it. Very simple approach. Let's run this. Yeah, you can see my factorial of 5 is 120. Very simple. Okay, let's see the solution in C and Java also. So here I have created a solution document where you can see solutions for every problem which I am explaining. Let's go to the end. Yeah, so here you can see the theory also, like just now what I have explained, you can see go through that also. So in C language, also there is input n and the factorial. In Python, it is dynamically typed language, right? So you no need to specify what is the data type, but in statically typed languages, you need to specify the data type, right? So factorial mostly take the large possible integer to store. Long is a large possible one. Like here I am declaring a fact is equal to 1, and after that same for loop, I is equal to 1, I less than or equal to n, I plus plus. Every time I am multiplying and just printing. So it is very simple. So in C language, while printing, you need to use percentage %d for integer and percentage %LLD for long integer. So it is a basic thing, you need to just remember it. And so what's the time and space complexity here? So here we can see there is only one loop running and nothing more computation is going on here. So that's why the loop will be running for n times. So that's why the time complexity is big of n, and we are not using any extra spaces here. Like we are not initializing any extra arrays and all. So that's why no extra space is consumed. That's why space complexity is big of 1. And I have explained a recursive approach also for this. So in interviews, you may ask a question to solve this problem in recursive approach. So in that case also it is very simple. Just write a logic with edge case, like whenever n is equal to 0 or n is equal to 1, just return the 1. If not, then return n into factorial of n minus 1. And very simple. And you can call the function from the main function. And everything is same. And in the recursion, the for loop is fine. In the recursion, time complexity is big of n only, right? But the space complexity, just because of the recursive stack, the stack will be gone up to n times, right? So n number of calls will be happening. So that's why we are using a stack of size n. That's why the space complexity is big of n. So that's the only difference. Apart from that, everything is same. In Python, just we have seen. In Python, we have recursive approach also. Like the same thing in C language, just define one function. Edge case is n is equal to 0 or n is equal to 1, just return 1, or else n into n minus 1, and just call the function. That's it. And let's see in Java. So Java is a statically typed language. So you need to specify what is the data type which you are storing. So here I am storing in long. So here n is fine. N is equal to 5 input integer, but the factorial should be in the long integer. And after that, just one for loop which is going from 1 to n. Every time I am just multiplying it with my loop iterator I and printing. So in the Java recursive approach also will follow the same thing, like in a recursive call, n is equal to 0 or n is equal to 1, just return 1 or else factorial of n into n minus 1. Very simple. And just call the function in the main method. So this is basically a recursion concept in C, Java and Python, and with time complexities. And let's go to the next problem, which is power of a number. Basically, what's the power of a number? So power of a number means multiplying a number by itself at a certain number of times. So that's it, nothing more in it. So basically it is written as, like, if a is a number and b is a number, like if a power b is represented as a is multiplied b number of times. So basically this is called as a power of a number. So here a is called as a base and here b is called as an exponent. So here this you can also call it as a power also. So basically this is a power of a number. Let's take one small example, like 2 power 3 means 2 into 2 into 2, which is equal to 8. Like in same case 5 square, like 5 into 5, which is equal to 25. So power in the sense multiplying the same number, multiplying the base number, how many times? Exponent number of times, or else power number of times. So that's it. That is the basic concept around this. But we have some special cases. You need to handle that. What are those special cases? So yeah. So in special cases in factorial is like whenever you are getting an input, so first you need to check whether the number is positive or not. So then only proceed. So that is one special case. So here what are the special cases? Like for a number, any number a, if the power is 0, then the value of it is 1. So for it is like for any non-zero a, like for any non-zero a, the value is 1. So anything power 0 is equal to 1. That's it. And one more special case, 0 power anything, like 0 power you can give any exponent or else power that is equal to 0. Like this is for b greater than 0. You can keep like, so it is very simple, right? So you are multiplying 0 b number of times. So what will be the answer? Obviously 0. And third case is 0 power 0 is considered as not defined. Like it is undefined. So it is mathematically indeterminable. That's why 0 power 0 is not possible. And in other case also you can take, like if you have a negative power. So negative exponent you have. So in that case, like a power minus b is considered as 1 by a power b. So these are some special cases you need to handle while solving power of a number. So what's the approach? So here also, like it is a pretty straightforward approach. We will be running one loop and every time we will be multiplying the number. That's it, very simple. So what's the approach? So very simple. So first initialize a result. So here also you need to think like we need to initialize the result with 1 multiplicative identity, not 0. Like if you initialize with 0, you will be multiplying everything with 0 only. So that should not be happen. So initialize with 1, and after that just run a loop. How many number of times? From 1 to exponent number of times. Why? We are multiplying the number exponent number of times, right? B times. So power number of times. So that's why run the loop that times. And after that, every time what we need to do? We need to multiply my result with base. That's it. Very simple. Multiply result by base each time. So let's take one small example. Let's take 2 power 3. So here what happens? So my loop will be 1, 2, 3, right? And first I will initialize my result with 1. So in the first iteration, what I will do? I will multiply my result with base, right? So here 1 into 2, that is equal to my result will be is equal to 2. So in the second iteration, what I will do? Again I will multiply my result with base. So what is my base? 2. 2 into 2, my result will be 4. And in the third iteration, what I will do? Again I will multiply my result with base. So my result is 4. So 4 into 2, which will be 8. So basically 2 cube is equal to 8. So 2 cube is equal to 2 into 2 into 2. Multiplying my base power number of times. So what is 2 into 2? 4, 4 to the 8. So that is what exactly we got at last, right? So this is a pretty straightforward approach how to solve power of a number. So here we will be having one base and one exponent, right? So okay, let's take base, BAS. Let's take base, which is equal to 2, and let's take one exponent, which is equal to 3. Now what we need to do? So first we need to initialize one variable, right? That should be consisting of the result when the loop is completed. So result, we need to initialize with 1, not 0, remember. And after that we need to run a for loop. So for I in range of, so the for loop also we need to run n number of times, right? N in the sense exponent number of times. So directly you can give exponent. So it will go from 0 to exponent minus 1, or else you can write 1 comma exponent plus 1, anything is fine. So every time what we need to do? We need to multiply the result with the base. That's it. So result is equal to result into base. That's it. So whenever the complete loop is completed, just print it. So print base power exponent is equal to and just give the result. Yeah, I'll just run this. Yeah, so we got the answer, which is 2 power cube is equal to 8. So you can add some more if conditions, like we have seen the cases, right? So 4 cases we have seen. So you can so these 4 cases you can apply those conditions and filter it before also, anything is fine. But this is the approach how we can solve this. So what's the time and space complexity here? So here for the time complexity, the loop is not, we have only one loop and nothing more computations is going on here. So the time complexity is equal to big O of n. So what's n here? So n is the exponent. That's it. So you can write big O of exponent Yeah. So what's the space complexity? We are not using any extra space here like arrays and all. So here the space complexity is also linear, which is big of 1. Big of 1. Yeah. And let's see in other languages too. So here you can see the concept also, like if you want, just go through this document. I have kept the link in the description. And yeah, let's see in the C language. So here the same thing, base and exponent initializing. After that we need to store result. It is a statically typed programming language. You need to take the highest integer storing, which is long, which you need to initialize by 1, and 1 for loop, which is coming from 1 to is equal to exponent, or else 0 to exponent is also fine. Anything is fine. After that, here we are just multiplying my result with my base every time, and after that just printing it. So very simple. Same time complexities. See, time complexity will not be depending upon the programming language. So it is just depending upon the code, pseudocode, that's it. And I have kept the recursive approach also, like how we can solve this, like the optimized approach. Like once go through this, like if for the even, if a power b, so this can be find out by a power b by 2 and multiply 2 times. So first you will be reducing the multiplication, and you will be calling it recursively, so that it is very it will change the time complexity from big of n to big of log n. And let's see in Python. So Python just now we have seen, and here I have put the recursive code also, and you can go through this. It is very simple. So let's come to the Java iterative approach. So here also the same thing, base, exponent, and you need to take the large integer long and just run a for loop, which is equivalent to from I to exponent, compute the result, print it. And I have put Java's recursive code also. Once go through this, the time and space complexity will go to log n. So this is basically what exactly is power of a number. If you like the video, just like, share and subscribe. Click on the bell icon. Thank you.